Welcome to the presentation, everyone. This is guards. And I'm not going to talk about these type of guards here, but rather what is known as guard clauses, guard expressions, guard tests, guard conditions, or often just guards in Erlang and Elixir. Now, why are these actually an interesting subject to talk about? Well, this type of programming construct does not exist in that many different languages. There are many languages that do not have something similar. But in a couple of other languages that do have support for pattern matching with guard tests, different design implementation choices have been made. And the implications of the design choices for guards in Erlang and Elixir might not be immediately obvious to people just starting out writing programs here. But they are important to understand because they restrict in some ways what kind of programs how you can actually write your programs. Now, in this presentation, I will mostly be showing Elixir code for two reasons. First, I have myself more experience with Elixir, being a professional Elixir developer now for 4.5 years, roughly. But the more important reason is that Elixir has some extra features that allow extra functionality on top of what Erlang already provides. And it's interesting to talk about this as well as the situations in which Elixir and Erlang have made different choices as how they designed the language related to guards. So there are 4 different topics that I want to cover today, and each of these topics goes into a bit more depth than the previous one. First, we're going to talk about what guards are exactly, both about their functionality as well as the limitations. Then we're going to look at what that means if you want to use one of the different conditional programming constructs that Elixir provides. After that, we are going to talk about what if you want to enhance the functionality of guards somewhat. What if you have, for instance, a very long guard expression that you don't want to remember all the time, so you want to alias it to a short alternative? Or what if you have some kind of macro and maybe you have different implementations, one that can work in normal code, but you like also it to work differently inside of a guard. After doing that, I'm going to share a little story with you about when I started out writing Elixir. I was a beginner myself, and I really wanted to add some extra functionality to the guard classes in Elixir and the mayhem that ensued, and why this may or may not actually be worth a couple of weeks of your time to do yourself. So these will be in slightly increasing levels of difficulty and going deeper and deeper into detail. This talk is very much focused on a beginner audience. I do, however, think that intermediate programmers of Erlang and Elixir will also learn something new here because there are very many interesting details and tidbits to talk about. So let's jump right in. What are guards exactly? Well, this is a simple question with a simple answer. Guards are an extension to pattern matching. Of course, this then begs the question, well, what is pattern matching exactly? Now, pattern matching is a powerful conditional programming construct that helps us to create very concise code to decide whether we want to run this part of the code or maybe this branch or this branch or this branch. And patterns allow us to do 2 things at the same time. First, decide which branch we want to take in our code, but at the same time, also extract some destructure or input to our bits of code. And by destructuring it, we get access to the different parts of our input, so we can easier read from it and manipulate it. Now, when I'm talking about powerfulness, which I will do a lot in this presentation, I am talking about 3 main parts of functionality that a certain programming abstraction might provide more or less of. First, we have readability, how easy it is for us humans to reason about it and understand what's going on when we see the code. Then efficiency, how easy it is for the compiler to optimize and then for the virtual machine to execute the code. And finally, flexibility. Is this abstraction usable in many situations or only in a few? And do we have to use a different abstraction for other situations? Now, of course, in an ideal world, we would like this magical silver bullet that would have all of these things in very high amounts. But in practice, that does not exist. And different ideas of structuring your programs make different trade-offs between which ones of these 3 is the most important. Now, pattern matching is certainly powerful. However, it is mostly focused on readability and efficiency. It is not that flexible. Here's an example of a mathematical function, a piecewise function. Here it's a definition of the absolute function, where if we have a positive number, we just return that. But if we input a negative number, we want actually to return its inverse. So we also always return a positive number. Now, we would like to write this mathematical function, implement this inside of Elixir or Erlang as a computer program. But it's not possible to write a pattern that matches this kind of input, because usually a pattern only matches one specific structure. And in many cases, for these kinds of conditions, we require to match a whole range or whole domain of inputs at one single time. So patterns are very readable and efficient, but not very flexible. And this is why already in the first version of Erlang, guards were introduced. And these are extra Boolean checks that run after a pattern has already matched, but before the code that we would like to execute then actually executes. And these make pattern matching itself slightly more powerful. So here is an example of how in Elixir we could implement this absolute function. And here in the green box, that is the part that is known as a guard test or just guard. Here's another example of a function where we compute the sign of a number that is 0 if it's 0, and otherwise either 1 or -1 if it's negative. Now, the sign function is an example that we'll get back to in a couple of times later in the presentation. So we now have an answer to the simple question, the basic core question, what is a guard exactly? It is this slight sprinkle on top of pattern matching itself to make it just this little bit more powerful. And that also means that guards can essentially be used anywhere that you can use pattern matching in Elixir. There's one exception here, and that is to the left-hand side of the match operator, the equal sign. You're not allowed to use a guard. And this is curious because in Erlang, they made the opposite choice. There you can also use guard tests to the left of the equal sign. So this is great. We can use guards to write quite flexible code. However, there is a restriction. We are actually not able to use any code we want as a guard test. We're only able to use a tiny number of built-in functions and operations in our guards. Some comparisons, some arithmetic operations, some type checking functions, and finally, some things that work with the built-in types. Actually, the last thing, the and, or, and not operations that are known in Erlang as and also and or else, those didn't exist in the first versions of Erlang, were only added later. So guards really were restricted and still are very much. And this begs for the question that many people starting out with Elixir or Erlang are a bit confused and puzzled by this. Why is it this way? Why do we not allow any user-written code? Well, the answer to that is that arbitrary code can do arbitrary things. What if your code is slow or goes into an infinite loop or tries to access something outside of your program? What if you want to or have to raise an exception? Or what if your code itself requires pattern matching, maybe with guards? So we have to have this strange nesting of pattern matching inside pattern matching. And these kinds of situations become very difficult to reason about for humans. So we lose the readability aspect. And also they become more difficult for the compiler to optimize and reason about. So they also become less efficient. The solution that Joe, Mike, and Robert made when they were building the first version of Erlang was to really make this restriction. You're only allowed to use this tiny subset of so-called built-in functions or BIFs. As a side note here, there are some guard functions that raise exceptions. However, what actually happens here is that the guard as a whole fails. And this, again, immediately creates extra complexity where we have extra syntax to work with what happens if a guard raises an exception, but we do actually want the other part of the guard still to work. So this is just an example to show you that if we are going to extend what guards can do by default, then we are immediately running into this problem of also having to support many different things and making it more complicated for us humans to understand what's going on. Now, many of the example code that you see when just starting out writing in these languages show you these nice short snippets of code where you're using pattern matching to branch between different things using the built-in data structures of Erlang and Elixir. However, there are many things that you cannot do inside of a guard. The more complicated mathematical expressions, for instance, like exponentiation and square rooting, are not allowed inside of guard classes. And as we've already talked about, nested pattern matching is also not possible. And that means that if you're creating your own custom data type, say a custom thing that is working like a number or a custom array or a sequence data type, then you actually cannot treat it the same way as the built-in data types. Even the comparison that is greater than, less than, those kinds of operators that you're used to pattern match on with the built-in data types, you cannot use them with your custom data types. It will not properly work inside of guard structures. And this is a bit unfortunate, and it creates a bit of friction, because in many code that you see, these simple examples, you see that people use patterns with guards to write their code, but you're not able to do that for your own abstractions. Now, as a side note here, different languages made different choices as to how guards were implemented. For instance, in Haskell, you're allowed to use essentially any code inside of a guard, but because of its type system, you cannot have arbitrary side effects in there. But F# goes even further and says, well, just throw any code in there you want. But as we've talked about, this does mean that in these languages, the compilers are not able to reason about it as effectively. And also for humans, it becomes more difficult to understand what is going on. Now, Robert himself talks in the Erlang rationale that he wrote about this problem as well. When guards were extended to be able to make these more complex guards using Boolean expressions, then rather than being treated as this tiny bit of extra sprinkle on top of pattern matching, many people came to see them as restricted normal expressions. And this creates this bit of friction. And that's something we will investigate further in the rest of this presentation. It leads us immediately to our next topic. In Elixir, you have different ways of writing conditional programming, where you choose between different parts of your code you'd like to run. Most importantly, the case, comment, and if statements. And for many people starting out with Elixir, it's not immediately obvious in which situation one should prefer one of these over the other. Now, the case statement is what we've talked about in the beginning part of this presentation, essentially, because the case statement really requires you always to use pattern matching with possible guard classes. The nice thing about the case statement is that it is one-to-one the same thing. It's built into the virtual machine itself. And in Erlang and Elixir, they are working exactly the same way. So as we've talked about, this results in a very readable and efficient thing. However, it's not very flexible because you really have to write your code using pattern matching with possibly guard classes. As a side note here, when you're writing your code with multiple function clauses, then this is actually turned by the compiler into one single case statement. To the virtual machine, these two ways of writing your code work and are treated exactly in the same way. It's nice, it keeps the virtual machine itself simpler, but it's something to keep in mind. Now, if you have some code and you're not able to structure it as a pattern match with a guard class, then there are two other tools that you can use. The first one of these are the if-else statements. Also, you have the unless statements that you can use. And here you can put any expression that you want, and it will work. So you're not limited to only using patterns with guards. How this works under the hood is that the result of your if-else is compiled to a case expression, but rather than pattern matching in the expression itself, we pattern match on the result of evaluating the expression, which is either true or false. Now, that's not entirely true, because Elixir allows other things besides true or false and treats them in the same way. So in certain cases, it has to resort to this slightly more convoluted way of writing the resulting case expression. This is because in Elixir, nil and false are both treated as falsy, and anything else is treated as truthy. So this allows for more flexibility, but it creates this slightly more complicated code when compiled. So it might not be as efficient. And for if-else, particularly when you have many expressions that you want to check for, many conditions, then of course the code by itself becomes hard to read. But then you have this final alternative, the cont expression, where this works in a similar way as an if expression, and it compiles down to very similar code. However, it looks very much like a case expression, where you have multiple conditions, one below the other, and then arrows to the right. However, in these expressions, these conditions, you're allowed to use any Elixir code you like. And as I said, they compile very similar to an if, where you have this nested case expression, but again, we only pattern match on the result of evaluating the expression, which is usually a Boolean, but in some cases, Elixir, when it's not able to see, check if the result will always be a Boolean, it has to result to the slightly less optimized form. So this is nice if you have to use something and you cannot shoehorn it into a pattern match with a guard, and you have multiple alternatives, and you can write it in this way. Now, as a side note here, Erlang also does have something which is called an if statement. And it looks very similar to cont. However, if is actually in Erlang an even more restricted version of case, where you only have the guard clauses and you cannot supply pattern matching with it. And that's why Elixir doesn't use it. On top of that, also Elixir requires both this truthiness, falsiness idea as well. So we've now looked at case, cont, and if, as well as functions with multiple clauses. And we need to talk a bit more about, okay, when should we choose one of these implementations over the other? We've already talked a little bit about readability and flexibility of these different ideas. However, what about efficiency exactly? Now, here are 4 ways of implementing the sign function using one of these abstractions every time. And my question to you is now, think for a minute about which one of these implementations you would expect to be faster than the others. We've already looked at essentially the core Erlang level here. What I've shown you, the code snippets that the code compiles to, were an Elixirified version of the core Erlang that shows up. I've shown you that as Elixir, not to introduce yet another syntax to people who are new. But now let's actually look at the bytecode at the after the final step of compilation. So this is what actually ends up being executed on the virtual machine. So my question to you is, which implementation of the bytecode are we looking at here? And I will step you through the code so you can figure out what's exactly going on. In these first 4 lines, this is just some metadata telling the virtual machine, hey, we have a function here. I've blanked out the function name to not spoil the fun here. Now then, when we actually start running the function, we test if x is equal to 0. If so, we return 0. And if not, we perform the second check. Here we test if 0 is smaller than x, or one could also say if x is larger than 0. Those 2 things mean the same thing. And if so, we return 1, because then we know x is positive. And otherwise, we return -1, because we know x is negative. So there are only 2 checks involved in this function. So which implementation of the ones that you've seen previously would result in this bytecode? Well, the answer is a bit surprising. It was at least to me a little bit, because all of them result into this optimized bytecode. And of course, the disclaimer here is that this is a tiny example, and it's very possible that for larger programs, the same would not hold true. But the main takeaway here is that optimizing compilers are amazing, and you should not think too hard about efficiency when starting to write your code. Only if later you find out that somewhere there's a bottleneck, that is when you should start profiling, benchmarking, and possibly looking at what actually ends up being executed on the bytecode level to find out if there's some place that you need to improve something. So mainly just think about readability and possibly the flexibility of your abstractions. Now, in certain cases, we do want to improve what we can do with, for instance, our custom data types. And in this part of the presentation, I will go a little bit into metaprogramming into Elixir. So when people who have just started out writing Elixir or Erlang might get lost a little bit in this part. I hope to be able to follow you along. And otherwise, there's still a 4th part of the presentation where you can easily pick up again. The first tool that Elixir provides to make it easier to work with guards is defguard. And this allows you to create a short alias for a much longer, more complicated guard expression, so you don't have to remember and write out that long version all the time. Now, defguard also performs a couple of extra checks at compile time to make sure that the guard you're actually implementing is working correctly. Now, here's a practical example. In Erlang and Elixir, we often use OK or error tuples to work with results that might indicate failure. And in this example, I would like to match on anything that is a successful result and not match on anything that is a failure. And rather than writing out all the cases by hand, I could write a nice guard for this, but of course the guard that I wrote here is impossible to remember, but therefore I can use defguard to create this short is okay alternative, and I can just write that one instead. Now, in certain situations, using defguard might not be enough. There are some not very common situations in which it might make sense to have different implementations of some kind of piece of code between normal Elixir code and guard-safe Elixir code. Maybe you can have some support, even though it's maybe more limited in your guards with relation to normal code, or you might have a simple algorithm that works in normal code that can use functions other than the guard-safe functions. But there is another implementation that maybe is a little bit less efficient, but it still works inside of guard classes. Now, one example here would be the number operators that are part of the numbers library, which allows you optionally to override the mathematical operators, that is plus, minus, division, and multiplication. And how numbers does this is by checking whether we are in normal Elixir code or in guard code, and in guards falling back to the kernel implementation. When we're writing macros, we have access to the caller environment variable or environment structure, and we can look at the context field to find out whether we are currently compiling normal Elixir code or guard code, or possibly whether we are in a pattern match. And in this way, we can create different implementations depending on the context we are currently in. Now, if that went a little bit over your head, that is not a problem. The main takeaway here is that there are some tools that you can use to reduce the friction of working with custom data types inside pattern matching and guard classes. They cannot do everything, but they do allow something, and that's already great. Now for the final part of my presentation. And this is when I just started out writing Elixir, I found out that there was an algorithm, and for this I really needed access to a modulo operation. And then I spent 2 weeks working on this and way too much time thinking about it, hours of sleep I didn't have at night. It was a very interesting adventure, to say the least. So what is modulo? Modulo is similar to the remainder operation, which is built into Erlang. There it's called rem, so also it's built into Elixir. However, the difference is that for modulo, the result is positive as long as the number we are dividing by, the divisor, itself is positive. And therefore, there are many algorithms that use it as a precondition. For instance, if we want to check whether a number is odd, we could check whether dividing it by 2 results in a remainder of 1. It works great. Rem works for both. However, using rem for this implementation would only work for positive numbers, where using mod would work for positive as well as negative numbers. Now, as I said, mod itself is not built as one of these built-in functions into Erlang, so we have somehow to build it ourselves. Now, after this discussion that I had, well, I tried building this and shared it with Jose Falim and the other people of the Elixir core team. We ended up implementing a non-guard safe version that is in the integer module now. But today we will talk about what is involved in writing a guard safe mathematical function instead. So Wikipedia is very helpful and tells us that if modulo itself is not built into a language, we can write it using this slightly more complicated mathematical expression, provided we have floored division. However, floored division itself is not built into the language. The built-in div performs division in a similar way as to how rem is not the same as mod. So how can we write our own floored division? Well, I wrote this truth table to see when the result of div would be off by 1. And then after some clever thinking, I found out that we just need another div that checks for the sign, etc. So we have a more complicated expression, but this turned out to work. However, there's a slight problem with using this solution, and that is that the sign function itself is not guard safe. We've seen the implementation before that itself uses pattern matching with guards, but now we need a different implementation to work inside of a guard. There is a solution here where we can divide a number by its absolute value. Now, abs is one of the built-in functions. However, this breaks when we're trying to divide by 0. We can, however, also mitigate for this by making it even more complicated by dividing by the maximum of the absolute value, because only in the case where this is 0, we divide by 1, and otherwise we divide by the number's absolute itself. Now, it becomes super complicated, especially since max itself is not guard safe, so we have to also create a new implementation for that. Now, the final thing that we end up with is this great number of new functions, and when we write all of that out, we have this beautiful, complicated mathematical expression that nobody would actually like to use in practice. So yeah, this was a big oof. I shared this with the Elixir core team, and they told me, yeah, there's no way this is ever going to make it into Elixir itself, for obvious reasons. Now, a couple of weeks later, I found out that actually there is a slightly more optimized way we can do floored division that uses some nice bitwise arithmetic. That makes the expression a little bit simpler, but still, it doesn't really is that optimized. And therefore, guard safe modulo was never built into Elixir. You can find some this implementation on GitHub, but you are not able to use it inside of guards. And to my knowledge, I really missed the modulo operation 4 years ago, but I don't believe there were many other programmers who had the same problem I had back then as a beginner Elixir programmer. However, for this presentation today, I've taken the time to actually benchmark the different implementations against each other, just to see how they actually perform in practice. So in my benchmark, I took a list with 10,000 pairs of integer numbers and applied each of these different operations to them, and then saw how often per second we could do this for 10,000 numbers. And actually, the results were a bit surprising. As baseline here, we have the remainder function that is built in but doesn't have the correct result for all inputs. Then we have the non-guard version that's built into the integer module of Elixir nowadays. And we have the optimized and non-optimized guard versions that I've just shown you and talked about. And actually, it turns out that the non-guard version, that is the optimized version that works inside of a guard, is only 1.5 times slower than the non-guard version, and only 2.2 times slower than the built-in remainder function. So this was a bit surprising to me. And again, the conclusion here is that optimizing compilers are awesome, and they're able to take this very complicated expression and still turn it into quite performant code. So the main takeaways from this presentation as a whole is that patterns with guard tests can be really useful to write readable and efficient code. And there do exist extra tools inside of Elixir to make them even more powerful and flexible. However, if you're not able to write your code using patterns with guards, don't fret, because the compiler will, with high likelihood, probably still be able to optimize your code to something that is efficient enough. So don't think about efficiency too hard when structuring your code. And if you do think that something might become a bottleneck or is a bottleneck, then you should profile and benchmark and maybe look at the compiled bytecode to be sure. For now, thank you very much for listening to me today, and just keep on programming, build amazing things, and relax in your hammock while going through life. I have been Martin, known on the internet as QQWY. I work at a small company here in the Netherlands, in Groningen, called Resilia. We build some of our own Elixir projects, but also do consulting for other companies all across the globe as well. Thank you very much, everyone, for listening to my presentation. And now I would love to answer your questions. Eric, you're muted currently.
Now I can unmute myself, so that's easier. So thank you very much, Martin. This is a great walkthrough of the ins and outs of guards. So big hand, virtual or otherwise, fantastic.
Thank
you. Checking out now if we have any questions on Whova. Bear with me for a minute. We don't have any questions on Whova, what I can see. Do we have any questions? I think we are running out of time, actually, but I open the floor for questions from the audience on this really exciting presentation on guards. So please.
Yes, and of course, if you have questions after my talk, I will be here at the conference today and also tomorrow. And also after that, you can find me on Whova, but also, of course, on the Elixir Forum and elsewhere on the internet as well. And I would love to answer all of your questions whenever they arise.
Yeah, that's a very good point, Martin. I mean, use the community boards or virtual meetups in Whova, or Twitter, or your preferred social media or digital channel. Maybe I will ask you one question if there's nothing from the audience. Since you have been studying this quite extensively, what would you add if you had the power? And maybe you do have the power. What guards would you add to Elixir, say?
That's a great question. Well, something I would like to experiment with is actually to create some kind of meta programming capabilities that would allow pattern matching inside pattern matching, essentially. And how this could work under the hood is just to expand one line of code that has a pattern match with a guard class, not to one line of built-in code, but rather to multiple clauses that each deeply match one of the different alternatives. And yeah, we could see if that might help people to write more flexible code, if it might become easier and people like it to work with their, for instance, their custom data structures. However, what then does happen is that the divide between the high-level code that you write in Elixir and the actual code that you end up compiling down towards become more and more different from one another. And that might be, so it might, that's one disadvantage. And also, of course, the size of the compiled code will become larger of a result. So that's something I would like to test out with if I ever have enough time to tinker with that. But yeah, there also is definitely something to be said to keep guards as simple as possible. And you see in the Elixir community and yeah, a little bit these two camps, where on one hand people want to keep it as simple as possible, and on the other hand people want to have it as flexible as possible. And I don't think I'm qualified to say who of these two camps is more correct than the other. But I do think that investigating different points in this design space would be very interesting to figure out new things in the future.
No, thank you very much. That's a great answer. And I think as you're highlighting, it's a trade-off, right? So as many things in life and engineering and development. So thank you very, very much, Martin. I just want to remind people that feedback is always good if you're a speaker. So please give Martin some feedback. We talked about the possibility of continuing the conversation on the Whova board. I would like to remind people on the Beam quiz, if you haven't taken it. That's a fun thing, and of course all our exhibitors and sponsors that help us bring this conference to you. So please visit them and see what they're up to and what's going on with them. So thank you for joining this session, and the big hand again, Martin, and everyone. Big hand, big applause, and please continue enjoying the rest of the conference. Thank you very much for now.